Good morning, class. Today's lesson is about the sum of an arithmetic series. Now you'll notice that I suddenly changed the word sequence to series. So what is the difference between a sequence and a series? In a sequence, you have semicolons between the terms. In a series, we want the sum of all the terms. So there are pluses between the terms. Now, should we have a sequence like this, 2, 4, and 6, we know it's an arithmetic sequence because the constant difference between two terms is 2. So what we actually did was to take term 1 add 2 and then we get term 2 and then you take term 2, you add 2 again and you get term 3. So to put it short, if we take term 1, we added the constant difference twice. So it's 2 times plus 2, and then you get term 3. We are going to use this concept when we do the proof of the sum of an arithmetic series. The sum of an arithmetic series has a special formula, and you need to know how to prove that formula. You have to learn the proof, you have to know the proof, and you have to say it whenever you're awake after you've slept. The proof is on page 3 of your notes, and we are quickly going through it now. If we take the sum of n terms, we have our first term, which is a. Then we add d to a to get the second term. And then we add 2d to a to get the third term. And we carry on like that until we get our last term. The term just before the last term will be the last term minus the constant difference. And the term just before that will be the last term minus 2 times the constant difference. Now if we take this equation and we swap it around, we put the last one first and the first one last, we will get this. Sn equals the last one plus the last one minus d plus the last one minus 2d plus the first one plus 2d plus the first one plus d plus a. Now let's number them. This one is equation number 1 and this one is equation number 2. Now let's add number 1 and 2 together. So it's number 1 plus number 2. If you add these two, you will get 2Sn. If you add these two, you will get A plus L. If we add these two, we get A plus L, and D minus D falls away. So these two added together will also give you A plus L. The same here, minus 2 plus 2d will give you 0, so only a plus l remains. The same here, l plus a, these two forms 0. Again we have a plus l, and the last two terms added together. So we get a row of a plus l's n times. Now we know the n here tells us how many terms there are. Therefore, we added these a plus l's n times. So now we have 2 SNs equals n times a plus l. Let's get rid of this 2 here to only get the sum of the n terms. So we divide by 2 on both sides. Then Sn will be n over 2 times a plus l. We know that our last term in the first row was Tn, just as we know that the first term is a. So our last term L can be substituted with Tn. So Sn equals n over 2a plus Tn. And we know that Tn equals a plus n minus 1 times d for an arithmetic sequence. So we're going to substitute the Tn with this part of the formula. N over 2a plus n minus 1 d. So what I actually did was take Tn and substituted it with its right hand side. Now if you simplify that, you get n over 2, a plus a is 2a plus n minus 1 d. And that is the sum of n terms in an arithmetic series. Let's look at a few examples. The first example that we are going to do is example E on page 1 of your notes. It asks, determine the sum of the first 3 terms in this sequence. Sequence because it has semicolons. Now first we need to determine, is it an arithmetic sequence or is it a geometrical sequence? So let's quickly see. Minus 4 minus minus 2 will give you minus 2. Minus 6 minus minus 4 give you minus 2. Because the difference is constant, we know it's an arithmetic sequence. So this will be D and that will be A. Now let's look at the question. Calculate the sum of, therefore we need Sn, the first 3 terms. So n will be 3. It's always good practice to write down what you have. So we know that n is 3 And we know we have to calculate the sum of the three terms. We know A is minus 2 and we know D is minus 2. So we use the arithmetic sequence sum formula. Sn equals n over 2 times 2a plus n minus 1 times d, close the bracket, and you just substitute all your values. The n is 3, so we have the sum of three terms equals 3 over 2. 2, the a is minus 2 plus n is 3 minus 1 times d is minus 2. And if you type this in on your calculator, you will get an answer of minus 12. So the sum of the first three terms of this sequence will be minus 12. You can always double check it. Minus 2 plus minus 4 is minus 6. Minus 6 plus minus 6 is actually minus 12. I'm now going to do the first three examples on page 20 of your textbook. So let's look at our first question. Calculate the sum to 30 terms of 3 plus 5 plus 7. Right. Calculate the sum to 30 terms. So we want S of 30. And because we substituted the 30 there in n's place, we already know that n is 30. First we need to determine whether this series, because there's pluses, is arithmetic or geometric. So let's get the difference. 5 minus 3 is plus 2. 7 minus 5 is plus 2. It's a constant difference, therefore it's an arithmetic series. We know that S of 30 must be calculated. Because n is 30, we can substitute n with 30. Our first term is 3, so A is 3, and our constant difference is 2. So D equals 2. Because it's an arithmetic series, we can use the sum formula for the arithmetic series. It's n over 2 bracket 2a plus n minus 1 times d, close the bracket. And you just substitute all the values. The sum of 30 terms will be n is 30 over 2 times a, which is 3, plus n is 30 minus 1 times 2 for d. And if you type that into your calculator, you will get 960. So for this series, the sum of the first 30 terms will be equal to 960.